We'll now look at the case when object is placed between O and F. That means we'll look at the sixth case, I hope. Here object is placed at O and F. We'll just look at object is between O and F1 in fact. So image is formed beyond 2F1. Now we'll just look at how it happens. So see here, you just consider a lens, a convex lens. This is a convex lens I have. Of course it has to be a thin lens, so it seems to be bulged. You have to consider it as a thin lens. So here this is the O, and here this is going to be the F1. This is going to be 2F1. Here it is going to be 2F1, double that, 2F1, and this is the principal axis I have. Now here the object is placed over here. In this case, the ray is going to be, so it will be going like this and will get reflected back, and then it will get reflected back over here. Then the image is formed somewhere here. This is AB, and this is going to be A dash, B dash, A dash, B dash. So here beyond 2F1, magnified, erect, and magnification is greater than 1 but positive because it's an erect image. Magnified, erect, and virtual. One more thing is virtual, because I am getting this as the positive. Virtual image you are getting. Here you need to get in this manner. So this is how you can take. So of course this is going somewhere here, this is going somewhere here, that is doesn't matter. Our focus is formed, our image is formed somewhere here. So this is how you can look at the image formation when object is between F and O. Image is formed onto the same side beyond 2F1, which is magnified. So these are the various cases for different positions starting from infinity to between F1 and O. So here let us say this is the F1 and between F1 and O. So here is the object. So earlier I was just writing this at F1, but before F1 and O. So between F1 and O, this is the size. This is the case where object is. So the image is formed beyond 2F1. So this is one more case of convex lens. Similarly, you can also think of concave lens. So whenever I think of concave lens, I'll just look at the case of concave lens. In case of the concave lens, just similar to your convex mirror. So here you can have a little comparison with the concave mirror acts similar to the convex lens, and concave lens acts similar to the convex mirror. So whatever the options you are getting for the convex mirror, just similar to that you will be getting, with a variation that here it has the two surfaces and there it has only one surface. So concave lens, when I think of the concave lens, this is the shape of the concave lens. This is the shape of the concave lens. And now when I think of this, so how is the image formation takes place, we have to look at. So here in this case, the very first thing I look at, when object is at, the very first case I look at, object is at infinity. Object is infinity. Then how the image is formed? Image is formed at focus on the same side. That is the thing here. Whereas in this case, the images are formed onto the other side for all the cases, almost all the cases except this last case. But in case of this, the images are formed onto the same side. So as an example, as the ray diagram suggests us, we'll just look at the ray diagram over here. So here, if at all I consider, this is the principal axis, this is the principal axis I am taking. So here, when you think of an object is at infinity, that means obviously you are getting the parallel beam of light. So it will be deviated in this manner. So this is the parallel beam, it is deviated in this manner. Similarly, when I think of this, it is deviated in this manner. So of course it is not above this, it will be through the surface, through the curvature. So here when I think of this, it is deviated in this manner. But when you extrapolate this, so all are meeting at a point which is nothing but the focus over here. So which are meeting at focus. So I can think of these things are meeting at the focus. So I can think of this is going somewhere here and which is meeting back at the focus. So this is the image formation, and here it is highly diminished and erect, virtual, and one more point you need to remember is m is far less than 1 but positive. That is one more point. So image is formed at focus. That's the point you need to remember in this case. So it is the case of concave lens. It is the case of concave lens. So this is a ray diagram. So object is placed at the infinity. So parallel beam of light is falling. That will be diversified over here, whose backward rays can be meeting at the focus. The image is formed somewhere here because the surfaces are inverted over here. That's the reason you are getting the image at this side. So this is the case of concave lens, the first case. We'll just now look at the generalized case of the image formation in case of the concave lens when object is moved from infinity towards the center of the lens. So obviously this is the principal axis, this is the principal axis we have, and now we are moving the object. So let us say this is 2f1 and this is f1. Then an object is placed over here. So a parallel ray which is falling onto the lens will be diverted like this, and if you take the extension of this ray will be merged at the focus. So this is how it happened. So this is how it merges at the focus. Similarly, the ray which is passing through the center of the curvature will be traveling like this. So this is how it travels. Center of the center of the lens. Center of the lens, it will never get deviated. It will fall as usual. Then these two rays are meeting somewhere here. Therefore, AB is becoming A dash, B dash, and the position is coming out to be F1 and O. So image is between F and O when object is between infinity and 2F, and here again diminished, vertical or erect, you can call erect, diminished, erect, and magnification is going to be less than 1, positive, and one more thing you need to remember here is position of this is okay and this is okay. Similarly, you can consider as you are moving towards this, let us say if it is coming towards at the point F1, then image is formed at infinity, just similar to the previous cases. So this is how you can just look at the case of concave lens for various positions. So this is one of the positions I have seen between infinity and 2f1. So these are the properties associated with the image formation in case of the position of the body between infinity and 2f1.